thank you for the opportunity to discuss the DIADEMA project. DIADEMA is an ongoing project at the early stage. For me, it's very important to collect feedbacks from an expert community on the project, also to correct the roadmap and to improve the results of the projects. Let me introduce briefly my institution. My institution is SYNLAB SDN, and IRCCS stands for Research Institute recognized by the Italian Ministry of Health for Research. We're a private institute, but financed by the Italian Ministry of Health. We belong to the multimodal molecular imaging Italian node. And essentially, our mission is to promote research activity in integrated diagnostics, in vitro and in vivo diagnostics. I show some numbers. This is important since I'm a physicist, and since I work for SDN, I know that I have the mission to get value from data. Since we acquire per year 1 million of laboratory tests, more than 30,000 nuclear medicine examinations, and more than 100,000 radiological examinations. We have a huge amount of data, and that deserves to be valorized. I'm the coordinator of image processing and AI laboratories, and I'm collaborating also with bioinformatics, 3D printing, and biobank. Our network includes several consortium, but I will mention also UCAIM, since by working in UCAIM that has been present during these days, I had the opportunity to understand best practices and good practices to deploy medical imaging data space, and how to work with data verification. And for me, it's very important. This slide shows a diagnostic workflow with some steps, starting from the patients with a clinical question and turning back to the patients with a clinical answer. We have several steps, and each of these steps produce data. And our mantra is that we have to work with for data management with and for AI, since such data collected at each step can be used to train AI models, but in turn, AI models can be useful to improve the efficiency of each step in diagnostic workflow. And this is exactly what we are doing in our daily activity as a mission. I'm sharing a previous work in 2021, published in 2021, but for me it's important, since in this work we showed that the standardization exists for many applications. For instance, DICOM is the standard for medical images, but is not adequately promoted and used, especially for typical task of big data analytics, for instance, data curation, annotation, and segmentation. In this case, we show and to the community that the majority of data collection and tools for visualizing and work with imaging data was not following the standards, for instance, for image segmentation, that is indeed DICOM-SEG. And in the UCAIM project, we are pushing on using DICOM-SEG for this specific task. Now I will explain the DIADEMA project. The background is that in 2021, essentially, work from Van Leeuwen showed that there are some unresolved challenges and barriers in the effective uptake of AI CE marked software for in medical imaging practice. There is some points that are the main points: scarce amount of data used to train and validate models, scarce availability of representative data in terms of real world, and intersubject variability. The majority of the CE marked software in 2021 there was 100. Now actually I think that are tripled the number of tools, and but the use of real world is crucial, since research data are not enough to train AI models. Lack of procedures to manage and improve data quality, and last but not least, integration into the clinical workflow of such tools. It is crucial. And looking at the rightmost picture, green boxes show the context of DIADEMA, that is a neuro, MR modality, and as a functionality of our proof of concept system is to provide a AI tool for triage of diagnostic workflow. The name DIADEMA stands for, is an acronym, stands for Novel Neuroradiological Workflow for the Assisted Diagnosis and Management of Dementia with Artificial Intelligence. Is about 1 million funded by the Italian Ministry of Health for 2 years, and project started last September. The partners, and I take the opportunity to thank all of the partners involved are SYNLAB SDN as a coordinator, University of Rome Tor Vergata, Fate Bene Fratelli in Brescia, in the north of Italy, and the University of Naples Federico II. And we are homogeneous across the Italian peninsula. The hypothesis behind the DIADEMA is that AI-enabled streamlined workflow can enhance diagnostic accuracy and reduce healthcare costs. First, since the AI-based protocol implementation can enhance the accuracy and reliability of neurodegeneration scores derived from routine MR neuroimaging, and second, integrating AI into neuroradiological workflow can bolster personalized and standardized diagnostic reports, and improving the management of patients' outcomes in dementia and Alzheimer's disease. In our project, we have 3 main specific aims. The first is to validate an AI protocol that supplies radiologists with the processed images and quantitative neurodegeneration descriptors from routine brain MRI. And this will be deployed by incorporating an automatic triage procedure into the workflow. Second aim is to create an efficient, integrated, and new radiological reporting procedures. Therefore, we will care how we release the results of AI boosted protocols. And third is to exploit also CT scans and to adapt essentially the protocols developed for MRI to CT scans, low-dose CT scans enhanced by AI for neurodegeneration marker assessment. This is the workflow. In blue lines show the radiological workflow, the conventional workflow, in which we have the patients, the MR scan, the images, and reporting step with the storage into the PACS system. With the DIADEMA, we want to develop a model engine that can support the neuroradiological workflow by providing tailored image processing, tailored report, assign the right radiologist, and assign the priority in answer to the clinical issue. The DIADEMA dataset is ongoing, and then we are collecting all of the dataset. It's composed by real-world data and brain MRI acquired during the last 20 years in our institution, more than 80,000 MR examination with clinical reports. That is a crucial source of information. Scientific community data. We will include also 10,000 MR exams coming from public data. Therefore, we mix public and private data. And to meet aim 3, paired CT MR neuro images acquired within 6 months, more than 500. Regarding the methods, in the next slides, I will explain better. We choose to use, but during these days, I have some other ideas that are growing about some other useful tools. But now we decided to use Girder for data management to develop in-house PACS scraping and image processing pipelines, to use a large language model for data labeling from clinical reports. And for the project, we have to label data with these labels: normal appearing, cerebrovascular, neurodegeneration, relevant artifacts, and other findings. We use obviously AI classification models for the DIADEMA engine and generative models for CT MR AM3. And last, Kapana for us is ideal, but I think that Kapana will be ideal also for other tasks for clinical deployment of the DIADEMA engine. Now I'm focusing on the tools. We chosen as a data format the BIDS. From format BIDS is an initiative that is establishing a formal standard for the management of neuroimaging data, and stands for BIDS, stands for brain imaging data structure, and essentially convert the information of DICOM in a meaningful, in a restricted but meaningful information for neuroscience. What we are facing now is that BIDS is intended for neuroscience, but neuroradiology is more than neuroscience, and we should include some additional concept to the BIDS format for our purpose. Second, for data management, as I said before, we choose Girder, that is a free and open source web-based data management platform. And we are working to make Girder able to deal with also federated learning. And the last, Kapana, that has been described some minutes ago. The expected impact of DIADEMA is the refinement of precision and efficiency in neurodegeneration assessment, elevation of computer-assisted radiological result communication, streamlining neuroradiological workflow, and very important, enhancing secondary use of diagnostic data by promoting fair principle in clinical practice. As a last deliverable of the project, we aim to deliver all the data collected during the project to the scientific community. And last, leveraging AI-enhanced CT scan for neurodegeneration marker assessment to provide a cost-effective solution or a preliminary assessment before MRI. What we are doing now at early stage, we are quite struggling with PACS retrieving information. Since you should imagine that a PACS, a 20 years old PACS, is a problem is a stratificated. There are several layers since during the years radiologists are changing, protocols are changing, scanners are changing, and the information within a 20 years old PACS is very complex to investigate. And for this reason, I do the analogy with archaeological layers and stratification problem. And another critical issue is the efficiency. We have to record, to collect, and to process 80,000 exams. This is not a conventional problem, and we should look at efficient procedures to get this. Definition and implementation of data selection and filtering procedures regarding brain anatomical region, and also technical relevance criteria, for instance, magnetic resonance contrast. Since each exam is complex, the contrasts are different, and we have to choose the right category for each image volume. And last but not least for importance is exploiting clinical reports by leveraging on large language models and AI tool for exam library. To retrieve information for PACS, we are designing we called this operation PACS scraping. That is indeed a strategy for efficient retrieval of suitable information from PACS. In the diagram flow, you can see each step of our design procedure. And with this procedure, we avoid waste of storage and waste of time, since we apply a either only archiving of images, preliminary either only, and we store effectively just the information we need before to convert them in bits format. For this, we use a DICOM toolkit. DICOM toolkit as a toolbox, but I think that Kapana could be useful also to do PACS scraping. As a final remarks, I show that artificial intelligence can have and is having a huge impact on clinical workflow. It is necessary to leverage data acquired in clinical practice. So private data, in my opinion, leveraging on private data is the solution to have effective AI models in radiology. And the DIADEMA proof of concept can be extended easily to other modality, other districts, and other pathology. But the challenge is to bring real-world data to a medical data space. And ongoing efforts from the community are going in this right direction, in my opinion. And it is essential to promote such initiative for data verification, but also for clinical validation and surveillance of AI-based models. And there is a need for suitable retrospective and prospective solution. For the DIADEMA project work on retrospective data, but I think that the solution is to collect directly in the practice data that are suitable for are directly suitable for big data analytics. And to stay updated on DIADEMA development, and we have also open position across all the partners from Italy, please send an email to diadema.research@gmail.com, and thanks for your attention.